Okay, Wildcats. Today we're looking at Wednesday, September 5th, transformations, and that's going to be on page 7. So if you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Now, these notes should look familiar because we did them with the transformation monster, but this time I've added some color to kind of emphasize it. Okay, so transformations. Okay, f of x equals negative a, parentheses, negative b, x minus h plus k. Now, when the negative in front of a, that tells you that it reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is inside the parentheses in front of b, it reflects over the y-axis. When b, which is inside the parentheses, is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. So if you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. Now, I've left some things off, so I'm just going to add them now so we don't have to make new copies. I forgot to add the parent function, which I'm going to abbreviate PF. So anytime you see PF, just know that's the parent function. Okay? So first thing first, example 1, we see the x in the squared, so we know the parent function is quadratic. Now you also notice that I've added lines. I do that before the video so I can keep the videos shorter. So if you need to pause the video to add the lines so your paper looks like mine, feel free to do so. You don't have to, but I like to try to keep my work neat and organized for you so the lines help. Okay. All right. Now, you can graph this, but we should be able to look at it and realize what the domain and range are. Okay. So here, the plus 5 tells us that we move left 5 units, and the minus 1 means we move down 1 unit. Now, because we know a quadratic is this shape, we know that the domain's all real numbers or an interval notation, and from this point, I'm kind of just going to use interval notation from negative infinity to positive infinity. Now, the range was from 0 to infinity, but because we went down 1, it's actually bracket negative 1 to infinity. All right, so the transformations. We have the 1/3, so that's a vertical compression of 1/3. We have the 4. Okay, now when it's in front, it's actually it's the opposite of 4, so 1/4. It's actually a horizontal compression of 1/4. That's tricky, I know, but that is what it is. Now, the plus 5 is opposite of what it says because it's in parentheses, so that's 5 units are left, 5 units. And then the minus 1 down 1 unit. All right, example 2. Okay, so here you have the number divided by x, so we know the parent function is rational. Okay, domain and range. Now, here the minus 3 tells us that we move right 3 units. Okay, so we know it's negative infinity instead of 0. So if you go right 3, it's 3 or 3 to infinity. Okay, now here the plus 5, remember the range was from negative infinity to 0, but since you go up 5, it's negative infinity to 5 or 5 to infinity. All right, so the transformations. So we have the 2 in the front, that's a vertical stretch of 2. We have the negative inside of the parentheses, so that reflects over the y-axis. Now we have the 4. And remember, when it's inside, it's opposite. So it's actually a horizontal compression of, it's not 4, of 1/4. It's my least favorite transformation because it's confusing, but it is what it is. And then the -3, we do opposite. So it's not going left, it's going right 3 units. And then last but not least, the +5 is up 5 units. All right, and let's look at example 3. All right, so we see the square root, so that's your parent function. Now domain, now remember domain was, or the parent bracket 0 to infinity and bracket 0 to infinity. But here, the +2 means we go left 2, so the domain is -2 to infinity, and the +1 means go up 1, so it's 1 to infinity. I'm hoping that you're starting to see that you need to memorize or some way to remember the domain and range of the parent functions. All right, transformations. So the 7 on the outside is a vertical stretch of 7. The +2, remember that's opposite, so it's not going right, it's going left 2 units. The +1 means we're going up 1 unit. All right, example 4. All right, so we see the 2 to the x. That 2 isn't a transformation, that 2 is the exponential parent function, so that's exponential. All right, domain. So here that -1 is opposite. Now the domain of exponential is, we know that exponential looks like this. Okay, so we know it's going infinite in both directions, so the transformation left right doesn't matter. The domain is going to be from -infinity to +infinity no matter what. But the range was parentheses 0 to infinity, but you're going down -4, so it's -4 to infinity. All right, transformation. So the negative on the outside just reflects the x-axis. Okay, the 3 is a vertical stretch of 3. And then the -1, remember that's opposite, so it's not going left 1, it's going right 1 unit. And then we're going down 4 units. All right, now remember, if you had some trouble with any of that, remember, I am going to have 3 groups in class, and one of those is traditional format going over these, so I can go over them again, okay? All right, let's look at example 5 and 6. Given the parent function and transformations, write the equation of the transformed function, okay? So vertical stretch of 2, that means the 2's in front, so we have f of x equals 2 log. Now left 3 means that's b plus 3, or not, I'm sorry, log base b of x plus 3. Sorry if that minor mistake there. And then plus 1, because b is the base. All right, example 6. F of x equals the absolute value of x. So horizontal stretch of 2, 1/2. That means it's f of x equals absolute value of 2x. Remember, it's opposite when it's horizontal stretch. And then right 1 means -1, opposite of what it says. And then down to -2. All right. Last examples. Identify the transformation, sketch a graph of the function, and identify the domain and range. Okay, So we know that this is a linear function. It's negative, so it's going down, okay? And we can use slope-intercept form to graph this, meaning the number in front of x is slope and the -1 is the y-intercept. So we start at -1, and the number in front of x is slope, so it's our rise over run. So we go down 2 to the right 1, down 2 to the right 1, down 2 to the right 1, down 2 to the right 1. And we can go the opposite direction, up 2 to the left 1, 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 up 2 to the left 1. Now we have the negative in front, so let's reflect x-axis. Let me not misspell reflect. Okay. And then the -1 is, oh, I'm sorry, the 2 is VS of 2. And then the -1 is down 1 unit. All right. Now let's look at example 8, the square root. Okay. So we know that the square root's points the parent function are 0, 0, 1, 1. The square root of 4 is 2. Okay. So we know that the vertex is at 0, 0. So let's transform that. So we know that we're going to go right 1 up 5. So from here we go right 1 up 1, 2, 3, 4, 5. Now, in order for it to be a square root function, it has to follow these directions. Okay. So we know from here we're going to go up 1 to right 1, up or to the right for 1, 2, 3, 4, up 2. All right, so for the transformations, we have right 1 unit, and then up 5. You really should write unit, but since there's kind of spaces limited, I'm okay with that. Oh, almost forgot. I forgot to write domain and range, so let's go ahead and add domain and range for example 7 and 8. Now, example 7 is linear. Its domain's easy for linear. The domain is from -infinity to +infinity, and the range is -infinity to +infinity. Now, for square root, we know it's the parent function is bracket 0 to infinity, bracket 0 to infinity. But it moved. So the left point isn't 0 anymore. In this case, it's 1, so 1 to infinity. And the graph went up 1, 2, 3, 4, 5, so it's actually 5 to infinity. All right, so at this point, you have two options. If you understood all the examples, then start working on the assignment. If you didn't understand some examples, just know that you could be in the small group working on this, and we can go over this again in class, and you can ask questions as we go through it. Or you could work in a small group with a partner that can help you with it as well. Okay, so with that, have a wonderful Wildcat